guys, today we are going to proceed with the part 2 of atomic structure. What you can see on the below of the video is the subtopics what we are going to cover today. The nucleus of the atom. Through experiments, Eugene Goldstein proved the existence of positive charges in matter. In his experiments, a perforated cathode was used in a discharge tube with air at very low pressure. A high voltage, about 10,000 volts, was applied across the electrodes. The observation was a faint red glow behind the perforated cathode. A small number of ions are present in this gas. When a high voltage is applied, these ions accelerate due to the electric field. These ions collide with the atoms of the gas. Due to this collision, the electrons knock off of them and create more positive ions. In turn, these ions and electrons strike more atoms and create more positive ions. These positive ions are attracted to the cathode. Some pass through the holes in the cathode. Goldstein called these positive rays as canal rays. The reason is because they were produced by the holes or channels of the cathode. These rays were not formed exactly at the anode. They were formed away from the cathode but closer to the anode. Therefore, they were known as anode rays or positive rays. Of positive rays. They travel in straight lines. They can move a paddle wheel placed in their path. They can cast a shadow of the objects placed in their path. These are positively charged rays. Therefore, they are deflected towards the negative plate when an electric field is applied. The EM ratio is not constant for positive ray particles, which are obtained from different gases. The nature of the positive rays depends on the gas which is in the discharge tube. Proton. The relative mass of a proton is 1. The mass of a proton is 1.6 into 10 to the power minus 24 grams or 1.007276 atomic mass units. We call it AMU. The charge of the proton is equal and opposite to the charge of an electron. The absolute charge of a proton is 1.6 into 10 to the power minus 19 coulombs. The relative charge is plus 1. In an atom, proton is the smallest particle that carries a positive charge. Radioactive emissions. Henry Becquerel and Ernest Rutherford showed that radioactive materials produce 3 types of emissions as alpha, beta and gamma. What you can see in the picture below is how this experiment was conducted and the pathways of these 3 radioactive materials. So these are the observations of this experiment. Alpha rays deflected towards the negatively charged plate. Beta rays deflected towards the positively charged plate. Gamma rays traveled straight. So, we can conclude that alpha particles are positively charged. Beta particles are negatively charged. Gamma particles have no charge. Therefore, gamma particles are not affected by an external electric or magnetic field. Rutherford's gold foil experiment. Rutherford conducted a series of experiments together with Johannes Hahn, Wilhelm Geiger and Ernest Marsden. Thin foils of gold and other metals were used for these experiments as targets for alpha particles which came from a radioactive source. What you can see in the picture is how this experiment was conducted. let's consider the observations of this experiment. Majority of the particles penetrated the foil either unreflected or with a slight deflection. Few alpha particles were scattered at a large angle. Very few alpha particles bounced back in the direction which it came. Rutherford suggested that most of the atom must be empty. He mentioned that, therefore, most of the alpha particles could pass through the gold foil with little deflection or with no deflection. Rutherford also proposed that the positive charges of the atom are concentrated in the nucleus of the atom. Neutron. In 1932, Sir James Chadwick discovered the neutron. The charge of the neutron is 0. The mass is 1.6749 into 10 to the power minus 24 grams or 1.008665 AMU. Rutherford-Bohr model. This model was suggested by Niels Henrik David Bohr. He combined the new learnings with Rutherford's ideas. This model states that the atomic nucleus is surrounded by electrons moving in orbits, just like planets moving around the Sun. According to him, with regard to electrons remaining in orbits, the electrostatic attraction that occurs between the nucleus and electron should be equal to the centrifugal force. In other words, electrons have to travel in a constant speed around the nucleus by maintaining the distance from the nucleus constant. Nucleons. These are particles found in the nucleus. This includes proton and neutrons too. Nuclide is the nucleus of an atom that has specific numbers of protons and neutrons. So, nuclides are composite particles of nucleons. This marks the end of the part 2 of chapter 1 of your chemistry lesson. See you soon with another video.